Hi there! Today I'll be going over what a milliradian is, how it works, and how we can apply it when we're out long range shooting. Let's bring it over to the whiteboard and get started. So I'm sure a lot of shooters have already heard the term minutes of angles, mils, milliradians, MOA, etc. It's basically just an angular measurement, a unit of angle. And from that we have equations such as like range in meters equals target size in meters multiplied by 1000 over mils covered. So this video basically kind of goes through how we could use this formula. Also, for those of you who are like me that likes to really dissect equations such as, simple equations like this or any other mathematical equations, then I hope this video can entertain you in a little bit. So we're just going to move on into radians now. So basically, by definition of a radian, it's mathematically defined as the angle formed when the length of a circular arc equals the radius of a circle. Thus, a milli, or 1/1000th of it, would be defined as a milliradian, right? So let's go over to the whiteboard, and I'm going to draw you a little circle. Here we go. And so by a definition of a radian, it's saying that, let's say the diameter is 2 meters and the radius is thus going to be 1 meter, right? From the distance right here to distance right there, that's going to be 1 meter. And by definition of radian, it's going to be when the circular arc, so this length, when this is 1 meter and when the radius is 1 meter, that's going to be defined as 1 radian. So because it's a unit of angle, it's kind of like, what am I going to use? How am I going to use this? Basically from there, we also know that the circumference, so let's see, circumference is 2 pi, it's 2 pi r. And basically how we got this is we know that pi, a lot of people just memorize it as 3.14 whatnot, but basically pi is also a ratio. It's a ratio of its circumference over its diameter. And for diameter of a circle, it's always going to be 2r. 2 times its radius. That's why we could just get the bottom here, take that out, make it 2r, multiply both sides of the equation by 2r. We're going to get 2r equals, 2 pi, sorry, yeah, 2r pi equals circumference. Right? So there we go, 2 pi r, 2r pi, whichever one works. Both of them works, because you're just multiplying it. So circumference is 2 pi r. So from that, we could get that we want to see how many radians are inside the circumference of the circle. So, that's really easily done. So we just get 2 pi r, divide that by r. Now r is going to be our radius, but also our circular arc here, because by definition of radian. So because of that, all that happens is that the r cancels out right here, and we're left with 2 pi. And because it's 2 pi, that's roughly, 6.28, right? 28 and dot, 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 just keeps on going. And so we know that there's going to be 6.28 blah, 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 blah radians in one circle. Now that we know that, we also know that in one circle there's 360 degrees. So 360 degrees divided by 2 pi, which is the amount of radians that we have is going to give us somewhere, yeah, I believe it was like 57.29, blah 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 blah. Let me get my calculator out real quick for you. So for, I've got here a TI-84, one of the newer holographic ones, but you know what, this little guy here works. It's a TI-30X, so we basically got 360 divided by 2 pi. You know what, I don't even know if this one has a pi. Let me just use this one. Right there, 57.29. Okay, sorry, my calculator was not in the correct measurement right there. So we have 57.2957795, and it just keeps on going. And from that, we have to divide this by 1000, right, to get our milliradians. So that's basically just going to be 0.057295775, and it just keeps on going. But because it's so fine, it's basically saying every mill that we dial in our rifle. The example for this Savage 10 FPSR, I already safety checked it. It's just got a SWFA straight 20 power scope on it. But basically, every time we click, so in this case, since it's 1/10 of a mil per click, every time we do a whole mil, so let's see if we can see that. So every time we click it, 1 mil right there. That means that we just move the internals of the scope by 0.05729577795 degrees. But because it's so fine, a lot of competitive shooters, they can't compromise for anything lower. They can't compromise for a low quality scope because they need to make sure that everything that they dial is spot on. Because at long range, this, like, let's say if it's 0.0573 instead of 29, basically, at longer ranges that could be a complete miss. So let me put this rifle away. Anyway, so moving on, because a mil is such a small degree, we could use trigonometric approximation to find out what a mil is in a certain distance. So let me erase this. Alright, so we already got that, right? And we know seven. So 1 mil could also be represented as 0.05729577795 degrees approximately. And because it's so small, we're just going to do a trigonometric approximation, right? So we remember that circle that we had there? We're basically looking at 0.057 degrees of it. So let me just draw a little circle again, and this is not to scale, but we're just basically taking this tiny little segment of it right there, and that's supposed to be 0.05729 degrees, so it's not, scaled. And basically we're going to take this and 29 degrees, and basically we're just going to use our approximation to a certain distance. So let's say that our target is 1,000 meters away. So that means that 0.05729 and the adjacent side of the triangle to this degree is going to be 1,000 meters. Now we want to find out what a mil would represent right here, the opposite side of the triangle in regards to this angle here. So that way we use something called tangent. Now tangent is also a ratio. It's just going to be the opposite over the adjacent. Adjacent. Okay, I can't spell. So basically what that means is that tangent, and when we put in like this degree, it's going to give us the ratio of the opposite over the adjacent. So in this case, the opposite is going to be a value of, let's say, x, because we don't know what it is. So x, and the adjacent is going to be 1,000 meters. So when we plug this into a calculator, what we're looking for, just this part, and you can put in, you know, really fine numbers there. That's basically just going to give us, I believe, 0.001, and we just double check. So on our calculator, we want to hit the tangent button, which is right there, tangent. We could plug in 0.057295775. There we go. And that'll give us 0.001. There we go, perfect. 0.001. And then now you might be like, well, what's that going to do with us? You know, well, how's that going to help us? Well, remember that tangent is going to be our opposite over adjacent. That means that this one is going to be 1/1000th of that meter. And you could also, you know, double check this by doing, so, you know, on the calculator, just like that, tangent 0.05729 equals opposite over adjacent. Remember, this is equal to this. So this ratio is equal to the value of tangent 0.05729. And thus, that way we, you know, bring over the 1,000 here, we multiply tangent by 1,000, so tangent 0.057 by 1,000, and we get the x is 1 meter. That's key right there. That's key. X is 1 meter. So what does that tell us? That tells us that 1 mil at 1,000 meters is going to be 1 meter. So this 1 meter here, that's going to be 1 meter tall. Perfect. Whew. So we got through that. Okay, and then so now it's going to be a little bit more comprehensive. Not a little bit now. So we have that there, and I'm just going to erase all this here now. Okay. So now a mil, I hope, well, I'm sure a lot of you guys already know, could be, when you look through a rifle scope, such as this one here, it's actually a quad mil reticle by SWFA, but a lot of conventional, like USMC, what do they use? They use a inertial, a straight 10 power scope. Let's say that that's a funky looking circle, but okay. So this is going to be their crosshair. And that's just going to be maybe like a target or maybe even a hunting scope. But what they have inside their reticle is, well, the USMC has kind of like a oval, but let's just make that a circle. We'll kind of make it like, I don't know, a Leopold mil dot scope here. Just like that. And so these distance right here, well, some of the reticles depend on the manufacturer, but most likely the distance from the middle of that dot to this one is going to be 1 mil. So that means that, you know, that the separation right there is 0.057, what was that, 29 blah 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 degrees. So as things goes further away, the mil is still going to represent 0.05729 degrees, but things are just going to be covered a little bit differently. So just remember that. And let's say that our target, we could draw our little target, you know, right here. This is going to be a target, just as a reference, so you guys don't forget. So that's our target, and when we look through our scope, let's say the target is covered by 1 mil. And also, remember, you know, depending on the reticle, 1 mil is usually also from the center of that to the center of the dot as well. So let's say the target is, by visually looking at it, is right there. Okay? So now, you know, you guys could be like, okay, well, range of meters is going to be target size. We have to get the target size multiplied by 1,000 divided by mils covered. In this case, it's going to be 1. But, you know, this video is basically just going to show you how that works in a more elementary way. Okay. The target's be 1 meter tall. Okay, so when something is covered by 1 mil, we expect that target, we expect it to be 1 meter tall when it's covered from this part to this part. That's supposed to be like, okay, yeah, it's supposed to be 1 meter tall, but more cases than, you know, than what it is, it's not going to be 1 meter tall. And so you might be like, well, how are we supposed to use this then? Well, basically, let's say that the target, well, in our example, is going to be 2.5 meters tall. So that's a pretty big target. So that's our expected one. But in reality, it's, well, for example, 2.5 meters tall. So then you might be like, well, you know what is how do we even use mils when it's 2.5 meters now? Well, because we expect 1 meter, 1 mil to be 1 meter at 1,000 meters, what is 1 mil, well, what is 2.5 meters tall for that mils? Here, I'll just draw a representation of what I'm trying to say here. So, you know, this is just a little segment of our circle again. We're saying what is the mils when the thing is 2.5 meters tall. So we're saying that this here is 2.5 meters. And because it's only covered by 1 mil, remember that the angle here is going to be 0.05729 blah 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 degrees, and we are looking for the range here. Now remember, 1 mil represents 1 meter here when the range is 1,000 meters, because, you know, remember tangent of 0.057 over 1, or well, basically tangent over that. Tangent 0.057 is 0.001. So that's a ratio, but in this case, tangent .05729, that's always going to be 0.001, right? But when we're going to put a variable in this, we're going to say it's our opposite. So our opposite to this angle is going to be 2.5, which I could do in this color. 2.5 meters. And we want to find our range. And it's going to be in meters as well, because the target size is in meters. So how we're going to do this is, now we're going to multiply both sides by range, and then we're going to, okay, I could show the steps as well. and I'm kind of running out of space there, so I'll just put this here. So we have tangent 0.057, blah blah blah, multiplied by range equals 2.5. Whatever we do on this side of the equation, we do on this side. So in representation, I'm sure you guys already know, what we're doing is we are multiplying this by range, and this side by range. Alright? Okay, and then this side crosses out, and we're left with 2.5. We have range times tangent 0.057. That's exactly what we have here. And when we do this, we are left with our range. So I'm just going to make sure the camera's getting all this. Yep, I think it's barely in there. Okay, so range in meters is going to be 2.5 over tangent 0.057, blah blah blah. And when we put that in our calculator, it should be 2,500. But okay, so let's do it together. So we have 2.5 divided by tangent 0.057 was at 29577, I think. Yep. We do that, we get 2,499.9999999. Okay, so that's 2,500 approximately. All right. So that gives us the range to be 2,500 meters. Wow, that is far. So when we're looking through it and the target's 2.5 meters tall and it's covering 1 mil, we know, because a mil is an angular measurement and also a unit of angle, that the 0.057 is always going to be constant if it's 1 mil covered, and the target's going to be 2.5. It's going to be 2,500 meters away. That is going to be a far shot. I guess not too much if you've got a 50 BNG or 338 log pull, but still, that's a long ways. That's a lot to correct for wind, and oh man, that's going to be an interesting shot. Okay, so we got through that. Whew. But we want to make this a little bit easier. I'm going to pause the video real quick. Okay, sorry, back again. Just wanted to erase that. So a better way to understand what we just went through is probably the explanation I'm going to give to you right now. So we know that 1 mil, this one's kind of dying. Let's see. There we go, that's a better one. 1 mil is going to be 1 meter over 1,000 meters. Remember, because 1 mil is going to be tangent 0.05729, and that's going to give us 0.001, which is 1 meter over 1,000. Okay, so with the same target being 2.5 meters tall, let me draw the target again. .5 meter target. We are basically going to say, you know what, we're going to be like, and it's still being covered by 1 mil, so here, we'll just put this here. Each hash mark is going to be 1 mil. And this one's still covered by 1 mil. Just like that, okay? So, 1 mil, it's just going to be a relationship, right? It's going to be, well, what's the expected value to be when 1 mil represents 2.5 meters? Well, we could say, well, that's our range. I mean, we already know it's going to be 2,500, but yeah, you know what? We're just going to forget about that. We're just going to follow that. Now notice that we can make this a linear relationship because 1 mil is this, 1 mil is that, and it's a linear relationship yet again because a mil is a unit of angular measurement. So an angular measurement is a unit of angle. So this way we have 1 mil is that, 1 mil is that, which means we could put this together. 1 meter over 1,000. Right? 2.5 over range of meters. And when we want to find the range of meters, all we have to do is multiply each side by range in meters and range in meters, and then it will cancel it out. So it'll be range, short for ran, just like that. And okay, so then there we go. 2.5 is that, and then so range times 1 over 1,000 is going to be 2.5, and then now we want to multiply each side by 1,000, so we could get the denominator of this out, and we get that, you know, here we go, that cancels, our range, which I'll write it over here, our range in meters is going to be 2.5 times 1,000, which is going to be 2,500 meters. Like, wow, you know, there we go. So we have a relationship of our mils, and our range is going to be 2,500 meters. Okay. Perfect. And okay, so now you might be thinking that this number is out of pure luck, and you did this because the thousands are there, and it makes this equation look, you know, better, and how this equation follows that equation. But actually, no. Let's do a different example, just to really hit this home. Alright, so I guess you could tell me, well, I'm going to tell you, but think about it. What is 1 mil? What is 3 mils at 1,000 meters, right? Okay, I hope you thought about it. So 1 mil, oh, did I say 3? Sorry. 3 mils, gosh. 3 mils is going to be what at 1,000 meters? Remember, because this is a unit of angle, so it's just a ratio, right? It's just going to be 3. So 3 mils is going to be represented as 3 meters tall at 1,000 meters. And let's see, what did I do in my example? 2.5. Okay, so then onto our target. Let's say the target's still going to be .5 meters tall, right? But this time, let me draw a better. Let me draw. Is that? I'm going to see if that's in the camera. Yep. So. Okay. And then always remember that you could find the mils from this side or that side, this side, that side. Just make sure you get, if you're going to do it on this side, you get this length here rather than this length here. But in this case, I like to measure it from the bottom up. That's just me. So each hash mark, or we'll just go with the balls again. Or around dots, the mill dots, right? Okay, 1, 2, 3. This is not to scale, by the way. And let's say, last time it covered only 1 mill, right? This time, it's going to cover 3 mills. Okay? So, it's going to cover 3 mills. Now we're like, well, what are we going to do with this? Well, easy answer to that one. We could say 3 mills, and we want a relationship again with what it's going to be at that distance. So we're going to be like 2.5 meters. What is 3 mills going to represent? Well, 3 mills is going to represent 2.5 meters. What's that distance supposed to be? We're going to visualize it again just to make sure we hit it home. Now remember that 3 mills, because 1 mill is 0.05729, 3 mills is just going to be 3 times 0.05729. And then, so it's going to be another relationship of this angle now for this length here with this length here as well. So we're going to be 2.5. Well, what is that going to be? We know that 3 mills at 1,000 yards, or 1,000 meters, excuse me. Right? 1,000 meters is going to represent something that is 3 meters tall. So we know this is going to be, we know that that length right there is going to be 3 meters, right? But what is it when it's only 2.5 meters? Because that 3 mills, this 3 mills is being represented by something that is 2.5 meters tall. Remember that one. This 3 mills is being represented by by something that is 2.5 meters. So that 2.5 meters would be right here. Right? And so we want to find out this range here. So to find this range, it's just going to be, you know, another relationship between the opposite angle, opposite side of the triangle and the adjacent side of the triangle. So it's going to be range. And also remember this is going to be in meters. And so here we go again. We have a linear relationship of 3 mills and 3 mills. That way we could equalize this equation to be the same. Three over 1,000 equals 2.5 over range. Okay, and then I'm sure you already know how to do this already. Multiply both sides by range, and then let's see, multiply by 1,000. You know what? I really want to show this to you, so I'm going to erase this part here. I'm gonna. Huh? Oh, I'm doing a video right now. Okay, so we have 3 mills. There we go. 2.5. So that was my little sister there. And we are. What was I gonna do? Okay, so. We have 2.5. Oh, okay. Sorry. Lost my train of thought. Okay, we got 3 meters over 1,000 meters equals 2.5 over range. And you'll see why I really wanted to show you this one. So we're going to multiply both sides by range. Whatever we do on one side, we have to do on the other side. cancel that out. We're left with range multiplied by multiplied by 3 over, you already know it's in meters, right? Multiplied by, since the range canceled out, 2.5. And then to isolate range, what we have to do is multiply, and watch this place, right? This is where everything ties into this formula. We're going to multiply both sides by 1,000. Okay? And this side by 1,000. Alright, you see, you're starting to see the correlation here right now. Remember, the 2.5 is going to be the target size. And so in this side of the equation now, we get that the 1,000 here is going to cancel out the denominator of the 1,000. So we're left with range times 3 equals 2.5 times 1,000. So it's going to be Alright, and to finish this off, what are we going to do? We are going to say that our range in meters is our target size in meters multiplied by 1,000 over 3. Now that 3 right there. And so that 3 could be represented as 3 mils. That's why we get our equation to be range in meters is going to be target size in meters multiplied by 1,000 over 3. Alright, we got through. That's basically it. So any kind of situation you go into, just get, how many mils, we'll make sure you get the target size. That's why, here, 1 second. Yeah, this is cleared out as well. In one of my range bags, it's just kind of a fun recreational bag that I just have a few of my things so I could just carry my cleaning kit, mags, whatnot. Got my temperature, compass. But anyways, I always carry a little measuring tape, just like that. It doesn't have to be anything fancy, just something that could measure in inches, and you could just convert that. And that's why it's also important to always memorize the conversion factors, because we live in I live in America, so we have inches and feet and whatnot, so we have to always, if we want to use this one, I have to always keep on memorizing it, the conversion factors. But anyways, there we have it. There's the explanation as to why this formula works, how milliradians work, the definition of milliradian. And also to this, I'm going to show you a little bit of something interesting as well. So, you might have already caught on to it. And this is basically kind of my equation. And I'm sure someone else already thought about it when they were coming up with this equation here. And they made it really simplified and really well. But you can also do this. So range in meters is going to be target size in meters multiplied by 1,000. Right, it's pretty much the same there, but mils covered is going to be the same as saying, oh shoot, sorry. Looking at the wrong page. Okay, there we go. Okay, so target size right there is going to be tangent mils covered multiplied by 0.057 2, 9, 5, 7, 7, etc. There we go. And that will give you the same range as this one. But this one is obviously much more easier to memorize, but I just want to hit it home again. Remember how mils are basically the angular unit, and or a unit of angle. Thus, this going to be that's going to be constant, and we just multiply by how many that was. That's why remember in the example below, it was like this, and then it was like 3 mils, and I pointed out to you that this is 3 times 0.05729, right? So that's just the same thing. And that will give us the same thing. So let's say target is 2.5 meters tall again. Right, tangent over 2.5 meters. We're going to divide that by tangent. And let's say it was covered by 3, multiplied by 0.05729. That'll give us 833 meters. Shoot, which reminds me, I forgot to give you the answer for the other one, right? So this one here, in our last example, our range is going to be 2.5 times 1,000 divided by 3. That's going to be 2,500 divided by 3. That's going to give us, what is it, 833.333, I believe. Let me do that real quick. Sorry. Yep, 833.333, and there we go. So this one and this one correlate. Perfect, right? Awesome. So now that we know that that works, I'm also going to give you just fun things for you to just keep in mind if you really don't have anything like a scope or anything, just a point of reference. Let's say you already know the height of a mountain or something, right? And you could use this same equations to find the range in meters. As we could, put our hand up here. It's like this. And here I have to reference to this paper here. The arm stretched out. 300 mils is basically the width of your hand from this part here to the end of the pinky right there. That's supposedly 300 mils, a rough estimation. And let's see, the next was 180. 180 is going to be your thumb to your pinky, so this part here, this knuckle to the very far edge of your palm, of your fist here. 100 mils is going to be with your 3 fingers. That's going to be your pointing, your ring, and your middle finger. That's supposedly going to be 100 mils, and 70 mils is going to be from the edge of this finger here and this finger here, and 30 mils is supposedly with your pointer finger. So if you're ever in a situation where you know something, it could even be like a telephone pole, but that's not going to be too much of an accurate reading, but maybe something like a mountain or a given height that you already know, skyscraper, I'm not so sure, and then just point out your finger, make sure the arm is straight, outstretched, nice and tight there. And you can be like, oh, that covers about 30 mils, or that covers about 70 mils, so that covers about what, 100 mils, 180, 300 mils, and then you could be target size that's already given to you, times 1,000 divided by mils covered, and I'll give you a range. I hope you enjoyed this video as much as I did. Thanks for watching.